Hello, in this video, I'll be discussing the effect of feedback on output impedance. I have already discussed the effect of feedback on input impedance. So here, uh, let Vs is equal to, we know that Vs is the applied input signal, okay, and Z0 as the output impedance, okay. Mm, impedance, and A is the open loop gain, that is gain of the amplifier without feedback. Okay, so if Vs is equal to 0, if Vs is 0, that means short circuiting the input. Okay, short circuiting the input and applying a voltage V causing current I, okay, to flow, then we can write V is equal to I times of Z0, that is output impedance, plus a VI. Here VI is the applied input signal to the amplifier. Okay, here you can write VI input signal to the amplifier, input signal to the basic amplifier. Okay, basic amplifier. So for example, this is equation number 1. Okay, this is equation 1. Now from VI is equal to Vs minus Vf, we know this, Vi is equal to Vs minus Vf. Okay, if Vs is equal to 0, this gives Vi is equal to minus times of Vf. Okay, this is equation number 2. Now if we put this value from equation 2 to equation 1, putting Vi from equation 2 to equation 1, what we can get? V is equal to I times of Z0 plus A times of minus Vf. Okay, this gives V is equal to I times of Z0 minus A Vf. Okay, now we know that since Vf is equal to beta times of V, this gives V is equal to I times of Z0 minus A Vf is equal to beta times of V. Okay, so from here V plus A beta V is equal to I Z0. Okay, so this gives V1 plus A beta is equal to I Z0. From here what you can get? V is equal to I Z0 divided by 1 plus A beta. So output impedance with feedback. So output impedance with feedback is ZOF. It is represented by ZOF. That is equal to V by I. So V we have already got here. That is that will give me finally Z0 divided by 1 plus A beta. Okay. So we are getting finally the output impedance with feedback is given by ZOF is equal to 1 plus A beta. So this is the relation. Now for negative feedback, 1 plus A beta is more than 1. Okay. So if you consider the two cases, the first case is for negative feedback. For negative feedback, this 1 plus A beta is greater than 1. This gives ZOF is less than ZO. That means the output impedance with feedback will be less than the case when there is no feedback. Okay, that is output impedance will decrease with feedback. Similarly, if we consider for positive feedback, number 2, for positive feedback, this 1 plus A beta is less than 1. This gives ZOF is greater than ZO. That means output impedance increases with feedback. Okay, that is output impedance will increase with feedback. ZOF is the output impedance with feedback. Okay, this ZOF represents the output impedance with feedback. So it increases or decreases depending upon the negative or positive feedback. I hope you have understood this. Thank you.